Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application class lecture number 10. Okay, in today's lecture I will discuss the application of section designer and design of different structure in SAP 2000. Okay, the lecture outlines are objective of this lecture, application of section designer, example on section designer, then introduction to the design of structures, then example on design phase in SAP 2000, and at the end class task is given for the student practice. Okay, lecture objectives are: by the end of this lecture the student will be able to model different section through section designer and design different structure in SAP 2000. Okay, application of section designer. Section designer is a integrated utility that is built into SAP 2000 that enables the modeling and analysis of custom cross section. Okay, by using the SD, you can create any complex cross section that is not available in SAP 2000, and the cross section will be created in the local axis, right? And you can also draw reinforcement inside the cross section where required. Okay, once any section is designed by using the section designer, so you can then assign it to any frame object. Okay, now how to access section designer? For that, go to define menu, then section property, right? Then choose frame section, then add new property, then select frame design type other, right? So this window will appear. When you choose the other, then from other you will choose section designer. When you click on the section designer, so section designer data form will open, right? So here you can change this the section name, right? Then select the base material of the section, then design type, right? Then concrete column design and check and design option. Okay, then you click on the section designer to open the section designer tool, and you can also check the section property and section modifier. If okay, once you click on the section designer, so this window will open, right? In this window you can draw or model your section. Okay, in this window the top bar is called the main menu bar. It includes different menus. Okay, the file menu contains the print setup, print graphics, exit this section designer tool and return back to SAP 2000, right? And edit menu, it contains undo, redo, delete and some other option like replicate command that required you. And view menu include different zooming option and show grid lines and axis. Okay, define menu contains the fiber layout. It is actually the reinforcement layout. And draw menu include different drawing option like drawing structure shape, draw solid shape and many others. Okay, in select menu you can select your different object. And display option, you can display different result like you can property show interaction surfaces for the column, and you stresses movement interaction diagram and show fibers. Okay, in the option menu you can set your preferences and color for your model or cross section. And help menu give you help related to your section designer. Okay, beneath the main menu there is a standard toolbar where different command or tools are available for use. Okay, this is the side toolbar where drawing tools and selection tools are available. Last bar is actually the status bar, and it will give you the status of your model like XY coordinates and the units. Okay, now I will discuss different option available in section tool one by one in upcoming. Okay, in section designer tool there is some predefined section are available for steel and concrete, so you can use that predefined section to draw or to model any composite section like this. Okay, in the draw menu there is some other section shape are available like rectangular and circular, you can also draw that, right? Okay, if you want to display the properties of a particular cross section, you just right click on that section. So this window will appear where it will give you the different properties. And there is a C model and S model, concrete model and steel model. You can also display these two models. Okay, like this. Okay, the concrete model is actually the stress strain curve, and this model is given by the Mander, and this is the unconfined model, right? This is for the concrete. Similarly, this is the stress strain curve for steel, right? Okay, you can also draw this kind of shape that is called trans shape, right? You can draw a poly shape for concrete, and you can also draw a reinforcement shape, either a one reinforcement or a reinforcement in one lane. Draw a reinforcement configuration in the form of rectangular or square and arm of circular configuration. Also draw a reference line, right? Okay, in section designer tool, a reshaper command is used to reshape your cross section. Okay, if you draw any cross section, so later on if you want to x and y coordinates for that particular point. Section designer tool, you can change the background dimension and color of different object. So for that you will go to the option, then choose a preferences. When you choose the preferences, so this window will appear where you can change the background grid lines spacing, and you can also change the fine grid spacing between grid lines, right? Similarly, you can also change the other option like the screen line thickness and some other zooming and snapping option. Okay, in order to change the color of your different object like reinforcement XY axis, so you can choose it from this menu. Okay, in the display menu of the section designer, you can display different option like you can show the section property, you can show the interaction surfaces, you can also show the movement curvature curve, and actually this is the movement curvature curve, right? You can also display this curve for a particular cross section. You can show the elastic stresses across the section, and you can display the show interaction surfaces for the column, right? That is the PM interaction diagram along with P, M2 and M3 values. Okay, now I will discuss how to model this cross section by using the section designer tool in SAP2000. Go to define, then frame section and add new section, and from there click on the others and choose section designer, right? So when the section designer window will open, solid section, and choose the rectangular section from here, right? And then draw this rectangular cross section at origin at 00 location. Then right click on the cross section, so the property box will appear. From there you can change the cross section dimension. When you make your reinforcement option yes in the property box, right, so it will by default shows the reinforcement at corner and at edges, right? In order to change the size of the bar and cover of the bar, you just right click on each bar and change the cover and bar size accordingly. Okay, when you just right click on each bar, so this window will appear. From here you can change the bar size, bar spacing and the bar cover, and you can also apply the above changes to all edges. Okay, in order to remove a particular bar, you just choose in bar size none value, right? So bar at that location will be removed. Okay, once you removed the all other bar which is not given in the example, then you will add the bar where you required. So for that you just click on the reinforcement option. From here you will choose the one rebar option, and you will put the rebar at the location where you want. So for that you will enter the X and Y coordinate for that point, or you can also draw a bar at any location, and later on you can just right click on that bar and you will just bring your the bar location to the actual one by changing the X and Y coordinates, and you can. Okay, once the cross section is created, Then we can display the different property of that cross section, like movement curvature curve, strand cut diagram, right? Similarly, we can display the section properties, like the area, the moment of inertia along different direction, and some other properties. Okay, once the section is developed, so it will be added in the frame property list, right? From here we can draw or assign this cross section to any member in the structure, either beam and column. Okay, now let's see how to solve this example in section designer of SAP 2000. Okay, first of all, define a frame section. Now, in order to access the section designer, go to define, then frame properties, then frame section, and then add new property. From here, choose the other, then select section designer, and from here change the name of your section if it is a beam, and I will keep all other values as by default, and I will select the section designer to access the section designer tool. So this section designer tool will appear, right? Okay, before drawing your section, kindly change the units. I will keep inches. Then change the background grid line dimensions. For that, go to option, then preferences. So background main grid line is spacing is 12 inches, but the fine grid between the main grid lines are 7. So I will change it to 11. So the total the boxes, each box will be 1 inches of dimension, right? Okay, in the example the cross section is rectangular, so I will go to a rectangular cross section. So choose the rectangular one, and I will draw this cross section at centroid at this point, right? So this cross section is drawn. Okay, but the dimension of the cross section is not as per the example. So what I will do, I will just right click on this cross section, and from here I will change the height and width of the cross section. The height in the example is 16 and the width is 12 inches. And there is also reinforcement involved, so I will keep this yes, and then click on OK. There is a reinforcement created as by default at corner and at edges, so we can change it according to the example. And in the example, the reinforcement are given 6 reinforcement is at this location and 2 at the top location, right? And at top location the cover is 1 inches, and at bottom location the cover is 1.5 inch. So I will change the other values accordingly. Okay, there is 2 reinforcement at the top. So first of all, I will remove this centered reinforcement. For that, click on this reinforcement, and then choose a none from the bar size, and also I will change the bar cover, that is 1 inches for top bars, right? So the center bar is removed and the cover is also changed to 1 inches value. Also I will remove these 2 reinforcement. So for that, just right click and choose none, and also choose none here. Okay, also I will change the bar size for top bar, and it is bar size is number 8. Okay, and the bar size here is also number 8. Now coming toward bottom reinforcement, I will change the bar size to number 6, right? And I will also change the bar size to number 6, and I will change the cover as well, that is 1.5, and I will change the bar size for this reinforcement as well. Okay, now I will draw this second row of bottom rebar. Let's suppose the distance between these 2 rows are 1 inches. Now I will determine the location of each rebar in the second row in the form of x and y coordinates. Okay, the location of the second row will be determined from the existing reinforcement, right? So for that, just go to the centroid of your existing reinforcement, and then check the x and y coordinate at status bar. Okay, for this reinforcement, the x and y coordinate is given by minus 3.63 and minus 6.13, right? Okay, as I told you that the distance between the rebar is 1 inches, so I will keep the reinforcement above this. It will be actually 1 inches above this reinforcement. So for the new reinforcement, the x and y coordinate will be obtained from this one. So the coordinates will be x will be remain the x, it will be minus 3.63, and the y will be reduced by 1 inches. Okay, so the y will be become minus 5.13. so how I will draw another row? So go for that, go to this option and then choose single rebar, and I will click on any location, and then I will right click on the rebar to change the location as required. Okay, x direction, as I told you, it will be remain the same, minus 3.63, and the y direction become minus 5.13. okay, you will add plus 1 inches. Okay, the bar size is 6 inches, so click on OK. It will be now it is exactly at the location. Another rebar, so the location of this will be 0 and minus 5.13. so I will draw a rebar at any location, and then I will change the coordinates. It will be 0, and this location will be minus 5.13, and the bar size is 6. Okay, for this reinforcement, the location will be 3.63 and minus 5.13. so again repeat the same procedure, and the location of x coordinate will be 3.63 and the y coordinates will be minus 5.13, and the bar size will be 6. Okay, right? So once the cross section is completed, we can display different other results like section properties. Okay, and we can display the show stresses values at different location, right? And we can apply the moment interaction curve, right? P, M2 and M3 value in case of column, and we can display the moment curvature, right? It will give you the strain diagram at different location. Okay, so once your cross section is developed, then you just cross the tool, then click on OK. so it will be added to the frame property list, right? Then click on OK. Now we can draw any member by using the same cross section that we have developed in the section designer. So for that, go to draw option and choose the beam that is created in section designer and draw your beam, right? And you can check its property. It is actually beam, and it can be assigned to any other member where required. Okay, if you want to do any further changes in your cross section, so you can access your cross section that is drawn already. Again, go to define, then section property, then frame section. From here you will just click on the modify and show property, then section designer, so that cross section will be open in the section designer tool. Okay, this is all about the application of section designer. Okay, design of structure. Structure design is the methodical investigation of stability, strength and rigidity of structures. Okay, the basic objective of design is to produce a structure that is capable to resist all applied loads without failure during its service life. Okay, the design involves materials, member type, size, reinforcement and configuration to carry load without failure. Okay, the following steps are involved in the design. Okay, first of all, the structure arrangement and configuration, where the architectural drawing including the location of different members will be decided. In the second step, the element shape and size like beam, column, slab and any other element shape and size will be decided. And in third step, the load will be calculated like the self weight, the live load, the dead load and any other kind of combination of load. Then perform analysis like to determine the bending moment, the shear force and any other response. Then do designing for the flexure, shear and any other response like torsion. Okay, once the design is completed, then last step is the drafting and detailing of your design. Okay, to develop the design sectional views, reinforcement location and its sizes, etc. Okay, design of beam involves the following formulas, right, in order to calculate the reinforcement. Fine. Consider the example in order to understand the design phase in SAP2000, right, and this is the beam. And first of all, I will design this beam manually and then I will solve it in SAP2000. Okay, now manual design. Firstly, the sizes or the trial section will be decided as per the ACI code. Let's suppose I will choose this as a trial section having 14 inches width and 20 inches height. Then I will calculate the self weight of the beam and other load calculation, right. So the total load 3.95 kip per foot is applied on the beam uniformly. Then I will analyze the beam for the bending moment and the shear force. So the bending moment, the maximum bending moment is at the center and its value is 2370.24 inches kip or 197.5 kip foot. Now flexure design. In the flexure design, the steel amount will be determined. Okay, so AS will be determined by trial and success method. So finally we obtain the steel area that is required is 4.37 inches square. On the basis of the area requirement, so I will choose the following two different options for the bar placement, right. Then go for the shear design, then drafting. Okay, this is the complete draft of your design. Okay, this is the cross section of the beam where the location of different reinforcement is shown. See how to design the beam by using SAP2000, right. So the methodology is divided into three phases. In the first phase, it relates to the creation of the model where the model different property will be assigned, right. In the second phase, it is related to the analysis, right, where analysis will be performed. In the third phase, where we will display different results and we will perform design. Kindly refer to previous lecture. Similarly for phase 2, again refer to the previous lecture. Once your phase 1 and phase 2 is completed, so this is the different results, right. Okay, the bending moment is exactly the same that we have obtained in the manual way, that is 197.5 kip foot. Now design phase in SAP2000. So for that, go to design menu, then choose either steel frame design or concrete frame design. So in our case, we will choose the concrete frame design. So here further option will be appeared where we can set and revise the preferences like different codes, ACI code and any other preferences that you want to revise. Then we can select the design combination, at which combination we want to do designing, so we can choose it from here. Once the following three option is completed, then we can start design. In view and revise preferences, you can change the following information. Similarly, you can select design combination. Once all the steps are completed, then we can run the design. Design is completed, so it will display the reinforcement amount at top and bottom direction, right. At center location, the bending moment was maximum, so for that the reinforcement required is 4.37 inches square, and it is exactly the same value that we have obtained on manually. You can also display the other results, like you just right click on the member, so this window will appear where it will give you the combination for which you perform the design. Then it will give you the top and bottom steel reinforcement at different location, right. Similarly, if you want to check the summary of the design, so you just choose the summary. So this complete summary of design of beam will appear, where the design of bending moment and the design of shear will be given. Okay, we can also display other design information. So for that, go to design, then concrete frame design, then display design option. So this window will appear. In this window we can display different design information like longitudinal reinforcing, rebar percentages, shear reinforcement. Then we can verify all the members passed or not. So for that, go to design, then concrete frame design, then choose or click on the verify all member passed. So it will give you all concrete frame pass the stress or capacity check or are designed. Similarly, we can also design a frame concrete structure. So for that, first of all, model your 2D or 3D frame structure, right? Then run analysis. Once the run analysis is completed, then you can perform designing. So for that, again go to design, concrete frame design, then start design and check of your structure. So your structure will be designed and it will give you the reinforcement at different. You can also verify all member passed. If any member or cross section is not fulfilling the requirement of the code, so it will be labeled with O/S. It means that it is O stress. In order to overcome the O stress situation, so you will either change the cross section, the materials property and other requirement. Okay, similarly we can also design steel structure. So for that, go to design, then steel frame design, then start design. Okay, once this design is completed, so it will give you either your particular cross section is fulfilled the requirement of the code or not. Okay, in case of steel structure design, auto select list of steel section can be defined in order to give you the most economical and most optimal cross section during designing. Okay, how you will define auto select list of steel section? For that, first of all, import steel section, then go to define, then section property, frame section, then add new section, then choose steel, and from here you will choose auto select list, right? And then add all different list of the section to this auto selection, right? And draw all your member by using the auto select list cross section. Okay, after analysis and design, it will give you the most economical and optimal cross section, and it will choose the different cross section at different location as per the requirement of apply load. Let's see how to design this beam in SAP 2000. Okay, first of all, create a new model. And spacing is 20 feet. Right, then define materials property, go to define materials and add new material. Let's suppose this is concrete 3 KSI, right? And the density of concrete is 150 pound per cubic feet, right? And it is 3 KSI, and I will keep the rest of value same. Click on OK. And now then define the rebar steel property. So add new property one. So it is a steel. Let's suppose it is 40 KSI steel, right? Change steel to rebar, right? And the other property for the rebar material, in case of 40 grit steel, it is 36 value, and FU is 58, FYE is 54, and the last value is 63.8. Click on OK. Click on OK. Then define the cross section property of beam. Go to define, the section property, frame section, add new section, rectangular one. So it is actually beam. So it is made of concrete 3 KSI, and the depth of this cross section is 20 inches and width is 14 inches, and change the concrete reinforcement design type from column to beam, and change the rebar steel to 40 ksi. Click on OK. Click on OK. Okay, now I will define the load pattern. So for that, to define load pattern, so that is already there, so I will just add live load. Click on OK. Now I will define load combination. 1.2 dead load plus 1.6 live load. Dead 1.2 and live 1.6. Click on OK. Now I will draw the beam. Right, now I will assign joints. This is hinge support and this is roller support. Right, now I will apply loads. So I will apply 1 kip per foot dead load and 1.5 kip per foot live load. First of all, I will apply live dead load. Select the member, then go to assign frame load, distributed load. Right, dead load, it is 1 kip per foot. Then I will again select it and then assign live load. It is 1.5. Right, now the model is ready for analysis. Okay, analysis completed. Now we will display the bending moment 33 in order to check either the value is same or not. Okay, it gives you exactly the same value, that is 197.5 kip per foot. Right, now we will perform designing. For that, go to design, then concrete design, and then we will select design combination. So I want design for 1.2 dead plus 1.6 live. So add to the design load combination. Click on OK, then start designing. Okay, once the design is completed, it will give you reinforcement at top and bottom location. So we'll change the unit to inches. Right, okay, it will give you exactly the same result that we obtained from manual design. So the maximum reinforcement required is 4.37 inches square. Okay, in order to display other results, you just right click on this beam, so it will give you the top and bottom reinforcement in different location. For summary, you just click on the summary, so it will give you complete summary of your design. Similarly, you can also display other results, like go to design, concrete design, display design information. So you can also display rebar percentages. Right, it will give you how many percent area of steel is at particular location. About how to design a beam in SAP 2000. Now let's see how to design a 2D steel structure by using auto select list. For example, this is a grid line for a 2D steel structure, and now I will define a frame section or auto select list for this structure. So for that, go to define, then section property, frame section. First of all, import W cross section. Right, then add new property. Right, then select auto select list and add all list of section into auto select list. Right, and change the name it to W sections. click on OK, click on OK. Then draw all your elements by using the auto select list, and I will draw all the element by using the auto select list. Right, now I will assign joints. All the joints are, let's suppose, hinge. Right, now we will perform analysis. Okay, once the analysis is completed, now we will perform designing. Go to design, steel frame design, then start design. Right, okay, design is completed. Select the different optimal and economical cross section at different location as per the requirement of the applied load. You can see over here W6 cross 15 cross section is selected for this portion, and similarly W6 cross 9 is selected for this portion. Okay, this is all about designing phase in SAP 2000. Now class practice task. Task 1 is about design the following section which is given below by using the section designer in SAP 2000. In task 2, design the 3D structure given below by consider it as a concrete or steel design. And for steel design, use W cross section in auto select list. Okay, thank you so much. This is all about lecture number 10.